All right, I'm back. Let's try this again. I'm going to zoom in a little bit here. So I'm going to start our next unit on solutions here. I don't want that to be blurry. Don't be blurry. All right, there we go. So I switched it to a black background with red. Why not get crazy, right? Actually, look at this. This is kind of cool. It's like a rainbow thing. That's pretty cool, too. Anyways, hope you guys are still doing all right. So next unit here is on solutions. And I'm just going to try and keep this to 10 minutes here. And then you're going to have a couple worksheets to do. So basically in chemistry, solutions are only created when like dissolves like. We talked about it. So like dissolves like means similar forces of attraction will dissolve similar forces of attraction. So if you take salt water, for example, if you put salt in water, you'll get salt water. It will dissolve, and the reason for that is you have similar forces of attraction. So you have Na plus, you have Cl minus, and then you have your water, which is polar. So it has partial positives on the H's, partial negative on the oxygen. So the reason salt dissolves in water is because the Cl is attracted to the H plus, and the Na is attracted, the Na plus is attracted to the O minus. And that was something from forces of attraction that I am gonna go over that homework later or tomorrow or something like that. So so this is just kind of review of the ion dipole interaction. But when solutions form, the only reason they ever form is if you have a polar dissolving a polar, a nonpolar dissolving a nonpolar, and then sometimes ionics dissolve in polar because of this. So if I erase this really quick, the way it works is your Na plus and your Cl minus get ripped apart, and I'm going to attach some videos from my website that kind of shows animation of this, but all the hydrogens, so if you have your water molecule, the hydrogens are going to surround Cl. Let me circle that here. And then all the oxygens are going to surround Na. H, 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 H. So all the partial positive hydrogens are attracted to the Cl, and all the partial negative oxygens are attracted to Na. So the water rips apart the salt crystal, therefore it dissolves. So basically solutions form when similar forces of attraction are mixed. And what you need to understand is if you have, again, if we use salt and water as an example, all right, so let's say you had a beaker full of water and then you put the salt in it. You know, imagine you can't see the dots, right? But the dots are the NaCl. The only reason it dissolves is because the attraction between salt and water is greater than the attraction for water and itself and salt and itself. If salt wasn't more attracted to water, it wouldn't make a solution, a homogeneous solution. And it's important you understand this is called the solute. This is the solvent. Water in regents chem is pretty much always the solvent, and solute is usually solid, but it can be liquid or gas. Basically, solute gets dissolved, so it gets broken down, and then solvent does the dissolving. All right, and now some solutes you can add way more than others. In other words, you know, maybe you can add 30 grams of salt in 100 milliliters of water. But another solute, like sugar or some other compound, you can't add as much. So best way to kind of explain that is the word solubility. And basically what that means is how many grams of a solute can be dissolved. You know what? I'm doing it again. I'm still upside down because my little contraption here, I have an iPad up here and I got boxes here. I keep forgetting it's upside down, so I gotta turn this around. I did it again. Sorry, guys. How many grams of a solute? I'll turn it around when I'm done. How many grams of a solute can be dissolved in a specific amount of solvent at a specific temperature? So the word solubility, how many grams of a solute can be dissolved in a specific amount of solvent at a specific temperature. So I'm going to move quick. You guys can always pause to rewrite something or look at it up or whatever. But basically what that means is, let's say you take NaCl and you have a beaker with some water, and you take another solid like Ki, and you have the exact same, imagine these beakers are the same size, same amount of water, same temperature, both at 25 degrees Celsius. So 25 degrees Celsius, you have 100 milliliters of water. Basically, when you put salt in here and Ki in here and you stir it up, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, you can only dissolve that much. If you add more than that, the salt will just spin around and settle at the bottom. It will not dissolve. But Ki, let's say I just added 3 times as much. So let's say this only holds 10 grams of salt and this holds 30 grams of potassium iodide. So that's what solubility basically is if you have the same amount of water, 100 milliliters, same temperature, 25, like roughly room temp, and you put 10 grams of salt, and if you add 1 more grain of salt, it will not dissolve. No matter how much you stir it, it will not dissolve. It just sinks to the bottom. Whereas Ki, you can add 30 grams, and then if you add just 1 more grain, it won't dissolve. That means you've maxed out your solution. This, we would say, has a higher solubility. Ki has a higher solubility because you can add more of it to the same amount of water at the same temperature. NaCl has a lower solubility because you can add less of it in the same amount of water at the same temperature. So that's what solubility is, kind of very quickly. What am I up to here? 8 minutes. All right, so I'm going to need a little more than 10, but it'll be pretty close. All right, so now your homework actually is talking about these. Here, I got it right here. So you're going to have this worksheet right here. I sent that through the Google Classroom. All right, and it's going to talk about salt dissolving. And then you're going to have this worksheet, which is on solubility curves. So I need to explain this a little bit first. So this worksheet, what's going on here is what we just talked about. So on this chart, you have 1, 2, 3, 4 solutes, and they're being dissolved in 100 grams of water. So just like the beakers I just had there, imagine you had 4 beakers, one with NaClO3, one with KNO3, one with KBr, one with NaCl. Based on the temperature of that water, these curves, they're called solubility curves, will change. So in that example I just gave you, I had 2 beakers at the exact same temperature. Well, if you change that temperature, increase the temperature, almost all substances, solids at least, you can dissolve more. So solubility goes up. So this chart is actually very similar to reference table G. So reference, and I'll turn this around. So there's table G, and you can see down here at the bottom you have temperature, and over here you have solubility. But this number here, I don't know if I can, yeah. This number here is how many grams you can dissolve in a beaker of water that has 100 grams of water. By the way, 100 grams is the same as 100 milliliters. It's the same thing. So if you have 100 grams of water, 100 milliliters, how much of these substances can you dissolve in that water? Well, the temperature will change that. So if you look at this one, KClO3, for example, if I have 100 grams of water and that water temperature is 10 degrees, I can only dissolve, I don't know, what would you say that is, 7 or 8 grams. But if I heat that water up to 40 degrees, that same substance, KClO3, I can now dissolve maybe 16, 17 grams in the exact same amount of water. I didn't add water, I just heated it up. So if you look at this, almost all these lines go up. The 3 that go down are actually gases. We'll talk about that some other time. But solids, what we can write here, we can write solubility curves here. And in general, for solids, as temperature goes up, solubility goes up. And what that basically means is, and again here, I know this is really messy, I'm going quick. I don't want to inundate you with videos and stuff to do. But basically, that's what this sheet is supposed to help you learn. That as you increase temperature, these curves follow how much of it you can dissolve in the same amount of water. So you're not adding water, you're just increasing temperature. All right, and they all go up. Some go up faster than others, meaning their solubility is higher, right? If you can add more, that means higher solubility. So I'm gonna have you do these 2 worksheets because I think that's best here than me going on and on and on. But that's the gist of it. So again, what are solutions? You kind of already know. It's when you dissolve something in water, but now we're getting into more specifics using table G soon. But these worksheets will get you started. Solids going up, yeah. So basically, I'm gonna just, as temperature increases, solubility here. As temperature increases, you can dissolve more solid solute in the same amount of solvent. So I know I screwed up in the beginning of the video again, but I'll get the hang of it. This is new to me too. This is kind of low tech. I tried some stuff, some other apps and programs to try and record my screen. It was kind of clunky. I was having trouble. I figured I'll just do this because then you can just go to my YouTube channel, which you already know about, and it's nothing new to learn or download or whatever. So I'll just basically do this as long as we're not in school, maybe a couple times a week, and I got to remember to flip it. So I'll show you things. I just have to remember to do it upside down, which is fine. It still works. All right. See you guys later.